Hello students. In this video, I start trigonometric functions. Already in your 10th standard, you are familiar with trigonometric ratios. Let me define what are trigonometric ratios. Okay. In a right angled triangle, the ratio of its sides and acute angles is the trigonometric ratios of the angles. Suppose I consider a right angled triangle, then one angle is 90 degree. You know the sum of all the angles of a triangle must be always equal to 180 degree. Suppose this is angle A, B, C are the vertices, means angle A plus angle B plus angle C is 180 degree. Amongst these three angles, one is 90 degree, means the sum of remaining two angles, angle B plus angle C, remaining two angles is 180 degree minus 90 degree, means that should be equal to 90 degree. So here, suppose it's a right angled triangle, then the highest angle is 90 degree. The other two are smaller than 90 degree only. Therefore, if the highest angle is this one, then the side opposite to the highest angle is the longest side. The side opposite to the highest angle will be the longest side. So this AC will be the longest side. Okay. So that longest side is called as the hypotenuse. Consider a right angled triangle. Right angled triangle. Suppose this angle B is 90 degree. The side opposite to this one, AC, is called as the hypotenuse. Okay. And suppose this is 90 degree. There are two unknown angles for them, but we know any one of the, suppose we add them, it is 90 degree. Suppose I consider any one of the angle as my reference angle. If this is my reference angle, angle A is equal to theta. The side on which our reference angle is lying, at that side is adjacent to this theta. That side and the hypotenuse are adjacent. It is quite clear this side is the longest one, it is hypotenuse, it is fixed. Okay, then the one more side which is adjacent to this theta is called as adjacent side. Okay, and now we are left with this side. This side is always opposite to our reference angle. Our reference angle theta has the opposite side as BC. So in this right angle triangle, if this angle A is my reference angle, then this BC will be the opposite side. We usually denote the hypotenuse as the symbol R, adjacent side as the symbol X, AB, the length AB is equal to X, and the side opposite to this theta, this line BC, is called as the opposite side, and it is usually denoted by the symbol Y. So hence there are three sides and one of the angle is 90 degree and one more is our reference angle theta. We have six ratios to be defined. Like suppose this is my theta, the side adjacent to this is X, that is adjacent side. The side opposite to this theta is Y, opposite side, and this is hypotenuse. It is quite clear because the side opposite to the largest angle will be the longest side. This is longest compared to these two. Okay, and also in a right angle triangle, by the Pythagoras theorem, you know the relation. The square of hypotenuse is always equal to the sum of squares of other two sides. Okay, now we can define six ratios between these. It is x by y, y by x, r by x, r by y, like that. And they are named as sine of angle CAB. Okay, it is sine of theta is opposite side divided by hypotenuse. Opposite side is here this length AB, that is y, divided by hypotenuse is r. Cosine of angle CAB, cosine of this theta, cos of this theta is adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. Tangent of AB, it is opposite side divided by adjacent side. We write it as y by x. Then there are three more ratios which are just the reciprocals of this. Cosecant of theta, cosecant of theta. It is shortly called as cosec theta. It is just the reverse of reciprocal of sine theta. So for sine theta, I say opposite side divided by hypotenuse. For cosec theta, hypotenuse divided by opposite side. R by Y, reciprocal. Then secant theta, next one. Secant of that theta is hypotenuse divided by adjacent side. The secant theta is the reciprocal of cosine theta. So it is R by X, reciprocal of it. Hypotenuse divided by adjacent side. Similarly, cotangent of angle CAB, cot theta, sorry, cot theta. Cot theta is the ratio of adjacent side to opposite side, and this is the reciprocal of tan theta. Thus, sin theta is y by r, opposite side divided by hypotenuse. Cos theta is x by r, and tan theta is y by x. The remaining three ratios, cosec theta, sec theta, and cot theta, they are just the reciprocals of these three respectively. I define co-ratios, reciprocal trigonometric ratios, and quotient relations. What are reciprocal trigonometric relations? Cosec theta is the reciprocal of sin theta. Reciprocal means the denominator for cosec theta will be the numerator for sin theta. Then reciprocal of sec theta will be 1 by cos theta. The reciprocal of sec theta is cos theta. Reciprocal of sec theta is cos theta, means I write sec theta is 1 by cos theta. Similarly, the reciprocal of cot theta is tan theta. So I repeat, cot theta is 1 by tan theta. And you can write it the reverse way also. Sin theta is the reciprocal of cosec theta. Cos theta is the reciprocal of sec theta. Like that also you can define. Next is quotient relations. Quotient means fraction form. Tan theta is the ratio of sin theta to cos theta. That's why you might have noticed sin theta is the ratio of opposite side divided by hypotenuse, divided by cos theta is the ratio of adjacent side to hypotenuse. This is the denominator, and this is the denominator for the denominator, means it gets cancelled with this denominator. We have y by x. What's y by x? Opposite side divided by adjacent side. That is the ratio for tan theta. Similarly, cot theta. Cot theta is the reciprocal of, ratio of cos theta to sin theta, and also it is the reciprocal of tan theta that we have discussed here. Okay. So with this, we have defined all the 6 trigonometric ratios. Now, let me find out some trigonometric ratios for some standard angles. Standard angles in the sense, in a 360-degree circle, we are going to consider in this right angle, in the first right angle to triangle here, okay, 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree as the standard angles. For all of them, I have a fixed ratio values. Let us discuss them, what they are. Okay. First, let me consider the trigonometric ratios for 60 degree. If our reference angle is 60 degree, then what are the trigonometric ratios? Already you have come across this in your 10th standard. Suppose I say my reference angle is 60 degree, then one of the angles is 60 degree. Okay, so sum of other two sides must be 60. So in order to find out the ratios, what I take is I will consider all the angles as 60, 60, 60 only. It is equilateral triangle. I have considered the equilateral triangle. But you have seen for all trigonometric ratios, we consider a right angled triangle. Trigonometric ratios can be applied only to a right angled triangle. Then only I can define opposite side divided by hypotenuse like that. So here, this is not a right angle triangle, means we have to make this construction. Draw this perpendicular from any one of the vertex to the opposite side so that it is divided into two right angles. Now, this is one right angle and this is another right angle. Now, suppose I say all these angles are 60 degree. This is divided into two parts, 30 and 30. Now, this is our 60 degree. For this reference angle, I consider in triangle ABC, let AB is equal to BC is equal to AB. All are of length say 1 unit. Okay, because all are equal. Let me consider all of them are of 1 unit. Draw AD perpendicular to BE. BE, then D, this point D is the midpoint of BC. If D is the midpoint of BC, then this length BC is 1 by 2, just half of the total distance. And this is also 1 by 2. Now, I forget about this triangle. I will consider only this sub-triangle. In this, we know this AB is of length 1, BD is of length 1 by 2. Then, can I find out what is AD by using the Pythagoras theorem? By using Pythagoras theorem, what I can say? AB square is equal to AD square plus BD square. So from that, I can find this AD as root 3 by 2. Okay. Now, all the sides are known for us. Okay. So what we have? For that theta, opposite side y is root 3 by 2. Hypotenuse r is 1. Adjacent side x is 1 by 2. So for this angle, I will describe all the trigonometric ratios. Sine of angle CAB, that is sine theta. Sine theta is here, sine 60 degrees. CAB is 60 degrees. Opposite side divided by hypotenuse. Opposite side is root 3 by 2 divided by hypotenuse is 1 means I get sine 60 is root 3 by 2. Similarly, cos theta, it is cos 60 degree. Cos is the ratio for adjacent side to hypotenuse. So x by r, x adjacent side, it is 1 by 2, hypotenuse is 1. Then tangent. Tan theta is the ratio of opposite side to the adjacent side. Okay, I have considered a triangle like this now. That sub-triangle. This is 60 degree and this side is 1 by 2. This is 1 and this side is root 3 by 2. Okay. Now, cosecant of theta. Cosec theta is the reciprocal of sine theta. It is the ratio of hypotenuse to opposite side. R by y. That is R is 1. Divided by y means root 3 by 2. Denominator of the denominator comes to the numerator. We have 2 by root 3. Then sec theta. Sec theta is the reciprocal of cosine theta. For cos theta, I define adjacent side upon hypotenuse. For sec theta, I define hypotenuse upon adjacent side. R by x. Our R is 1 divided by our adjacent side x is 1 by 2. This is the denominator for the denominator. It comes to the numerator. So secant theta is 2. That is sec 60 degrees. True, what it is 660. Cos 60 degree like that. Then cotangent of theta. Cotangent is written in short as cot theta. Cot theta is the reciprocal for tan theta. Cot theta is the ratio of adjacent side to opposite side. Adjacent side is 1 by 2 here divided by opposite side is root 3 by 2. Okay, 1 by 2 into. This I can write it as upside down 2 by root 3. This to get cancelled. I get it as 1 by root 3. So cotangent theta is 1 by root 3. Next, I consider if the angle, our reference angle is 45 degree in a right angled triangle. In case this angle A, B, C is a right angled triangle, then this angle C is 90 degree. Here you can notice. If my reference angle is 45 degree, remaining angle, this is also 45 degree. Now you forget about this angle. Only this one, 45 degree. Now, let me consider a triangle with angle B as 45 degree and angle B is 90 degrees. Now, if these two angles, if this is 45, then this must be 45, means the side opposite to this one and the side opposite to this one, both are of equal length. If it is 1, this is also 1. Okay, so thus in this triangle, what I have, AB is equal to, AC is equal to BC. Let me consider both are of length 1. Then how I can find out this AB as AB? By using the Pythagoras theorem, I can say AB is the root of. Okay, so the square of sum of other two sides, that is AC square plus BC square. AC and BC are of length 1. So 1 square plus 1 square means root 2. AB, I have got it as root 2. This is root 2. Now, with this background, I can write all the trigonometric ratios. So what happens? For sine 45 degree, suppose I take sine 45 degree, opposite side y, opposite side y, it is of length 1. Adjacent side x is also of length 1. Hypotenuse is of length root 2. So sin theta, if I say opposite side divided by hypotenuse 1 by root 2. For cos 45 also, adjacent side divided by hypotenuse 1 by root 2. Then tan 45. Tan 45 degree is the ratio of opposite side divided by adjacent side. Opposite side divided by adjacent side for this 45 degree. Means it is 1 by 1, it is 1. Then similarly, cosec 45. It is hypotenuse divided by opposite side, just the reciprocal of sin 45. This is 1 by root 2 means it will be root 2. Then sec 45 degree. Sec 45 degree is hypotenuse divided by adjacent side. Our hypotenuse is root 2, adjacent side is 1 means sec 45 is what? Root 2. Then similarly, cot 45. Now, I find the trigonometric ratios for one more angle 30 degree. 30 degree. If our reference angle is 30 degree, in the first while finding 60 degree you have seen, if consider an equilateral triangle 60 degree, 60 degree and 60 degree, draw a perpendicular, then this is 30 degree and this is 30 degree. I can consider any one of these as my reference angle. So here, if I forget about this side, okay, I consider only this one, then that looks like this one. Or if you forget the other half, if this you forget and this is 30 degree, then the triangle looks like this. So now, if the total length is 1, then this will be 1 by 2. I'll call it as A, B, C. Draw AD perpendicular to BC. Then our reference angle A is 30 degrees. The side opposite to 30. Now, it is 1 by 2. This is of length 1. Means this opposite side will be root of 1 minus 1 by 2. It's a square. 1 square minus 1 by 2 square. It is root 3 by 2. So thus, the adjacent side for this 30 degree, for our reference angle 30 degree is root 3 by 2. Once we know all the sides of a right angled triangle, then I can write the trigonometric ratios for 30 degrees. Sin 30, opposite side divided by hypotenuse. What is our opposite side for 30? It is 1 by 2. What is the hypotenuse for this? It is 1. Cos 30 degree. Adjacent side divided by hypotenuse. It is root 3 by 2. For tan 30, it is 1 by root 3. Then for cosec 30, 1 by sin 30 also you can write, because cosec 30 is the reciprocal for sin 30. Like that, 1 divided by sin 30 is 1 by 2. Denominator of the denominator comes to numerator, you will get plus 2. Sec 30 degree. It is the reciprocal of cos 30 degree. We know 1 divided by, what is cos 30? It is root 3 by 2. Since it is 2 by root 3. Cot 30, 1 upon tan 30, this is root 3. Now, two more angles are remaining, 90 degree and 0 degree. These are obvious angles. You see, if I would like to write the trigonometric ratios for 90 degree itself, at that time what happens? I have to first consider a right angled triangle. This must be 90 degree and our reference angle should also be 90 degree. Suppose if I'm considering this as my reference angle, this should also be 90 degree. When does this becomes 90 degree? When this line comes closer and closer and closer to this side and gets coincided with it. Like this. This line will come very close to this line and these two will become parallel to each other and then coincide. If they coincide, then the hypotenuse will become equal to the opposite side. R becomes equal to 1. In case if the hypotenuse becomes very close to the opposite side and becomes 0, then there is no adjacent side here. That adjacent side becomes equal to 0. Okay, I hope you have understood. So the hypotenuse gets coincide with the opposite side and the adjacent side, I will call it as x, that becomes equal to 0 and y is equal to r. With this background, assuming that this is theta and this theta is 90 degree, I have to write the ratios. While writing, what happens? Sine 90 is opposite side divided by hypotenuse. Our opposite side here is equal to the hypotenuse, means y and r both are equal. Y is equal to r means r by r. Sine 90 is 1. Similarly, cos 90. Cos 90 is the ratio of adjacent side to hypotenuse. What is our adjacent side? This reference angle is also 90 degree, means it is coincided with the 90 degree angle. At that time, there is no adjacent side. Adjacent side has become 0, means adjacent side divided by hypotenuse means cos 90 will be 0. Like that, tan 90. Tan 90 is the ratio of opposite side to adjacent side. Here, what is the opposite side? Opposite side and hypotenuse are equal. They may be of length 1 unit or any x like that. But adjacent side is 0. If the denominator is 0, then I have to write this function as not defined. And we usually use this symbol. Okay. Then the three respective reciprocals are cosec 90, sec 90, and cos 90. Reciprocal of sine 90, 1 by 1. If we take the reciprocal, it is 1 only. But for cos 90, the sec 90 is defined as 1 divided by cos 90 is 0, so it becomes not defined. Then cot 90. Cot 90 is the reciprocal of tan 90. Already we know tan 90 is 1 by 0. Denominator of the denominator comes to the numerator. Cot 90 will be 0. I hope you have understood. Okay. Now, I discussed one more last angle. It is trigonometric ratios of 0 degree. If our reference angle is 0. I have to consider a right angle triangle. This is my right angle triangle. And if this angle has to become 0, this is my reference angle, this has to become 0. When does my reference angle become 0? When this hypotenuse becomes false on the adjacent side. Here it is. On the adjacent side only, the hypotenuse comes and falls on it. When the hypotenuse falls on the adjacent side, hypotenuse becomes equal to the adjacent side. And then, now, there is no opposite side because this side has fallen, means this opposite side is not there. At that time, opposite side becomes equal to 0. So thus, if our reference angle is 0 degree, then suppose I call this as BC, A, B, C like this. Or BC is equal to AC. A, B, C like that. Okay. R becomes equal to X and Y becomes equal to 0. So with that, if I write the trigonometric ratios, what happens? Sine 0 is opposite side divided by hypotenuse. Here opposite side has become what? Opposite side has become 0 and the hypotenuse is become equal to the adjacent side. Then sine 0 is y by r. Y is 0 means 0 divided by anything. Sine 0 is 0. For cos 0, cos is the reciprocal of, ratio of adjacent side to hypotenuse. What is our adjacent side? It is r or x like that. But r divided by, this is also r I take, then r by r, cos 0 becomes equal to 1. Similarly, tan 0. Tan 0 is the ratio of opposite side to the adjacent side. What is our opposite side here? 0. Divided by adjacent side, x, that's equal to r, and both may be of length 1 like that. So 0 divided by anything means tan 0 is 0. Their respective reciprocals are sine 0 reciprocal is cos 0. It is 1 divided by sine 0 means 1 by 0. It is not defined. Sec 0, 1 upon cos 0. You know cos 0 is 1. So sec 0 is also 1. Tan 0 is 0. Cot 0 is the reciprocal of tan 0. We have 1 divided by tan 0 is 0 means cot 0 I am going to write it as not defined. Now, I write all these ratios in a box, in a table. I have considered the standard angles as 0 degree, 30 degree, 45, 60 and 90. In order to remember, if you remember all the ratios for sine theta, it is sufficient. The others you can write as they are. Because sine 0 is 0, sine 30 degree is 1 by 2, sine 45 degree is 1 by root 2. Root 2 by 2 means 1 by root 2. Sine 60 degree means root 3 by 2. Sine 90 is 1. For cos, what happens is the reverse of this line 0, 1 by 2, 1 by root 2, root 3 by 2. If they are written in this order back, that will be for cos. Because sine 90 degree is equal to cos 0 degree. Okay. Then sine 60 degree is equal to cos 30 degree. They are co-ratios. You will come to know that. Then tan, sorry, one more. Sine 45 degree is equal to again cos 45 degree only. Okay. Sine and cos they are called as co-ratios. Sine, so cos 0 becomes equal to 1. Cos 60 will be root 3 by 2. That is the ratio, cos 30 will be root 3 by 2. That is the ratio for sine 60 degrees. And then cos 45 is also 1 by root 2. 1 by root 2. This is also 1 by root 2. Then cos 60, it is 1 by 2. Cos 90 is 0. This slide is written in the reverse order. 1 root 3 by 2, 1 by root 2, 1 by root 2, both are same. Sine 45 degree equal to cos 45 degree equal to 1 by root 2. Whereas cos 60 is equal to sine 30. They are 1 by root 2. Why I told you? Because sine and cos are co-ratios to each other. Now, for tan 0, it is 0. Tan 30 degree, it is 1 by root 3. Root 3 by 3 is 1 by root 3. Tan 45 degree is 1. Tan 60 is root 3. Their respective reciprocals can be summarized in this table. Sine 0 was 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 is 1. Then sine 0 is equal to cos 90, sine 30 is equal to cos 60 degrees, sine 45 degree is equal to cos 45 degree. Remaining also you can define like this only. Then tan is just the ratio of these two. 0 divided by 1, 0. 1 by 2 divided by root 3 by 2, 1 by root 3. 1 by root 2 divided by 1 by root 2, 1. Root 3 by 2 divided by 1 by 2, it is root 3. 1 by 0 means it is not defined. Then cot theta is just the reciprocal of tan theta. 0 divided by 1, 1 by 0 it becomes, so it is not defined. Reciprocal of 1 by root 3, it is root 3. Cot 45 degree is also 1. Cot 60 is 1 by root 3. Cot 90 is 0. Similarly, sec 90 is the reciprocal of cos. Cosec 90 is the reciprocal of sin theta. I hope you have understood by heart all these ratios. In the next video, we shall see the trigonometric identities. Okay, thank you.